of Mumbai and Maharashtra. During the last 39 years of experience in civil and environmental engineering, he has completed many housing and infrastructure projects, including the Metro Rail project. At the Institution of Engineers India, he's held the position of Honorary Secretary from 2010 to 2012, and as chairman of the Belapur Local Center and as a council member for the period from 2012 to 2014. He has been a convener for Environmental Engineering, Maharashtra State Center for 2018 to 2021. He's also held the position as member of ENDB, Technicians Chapter and Water Management Forum. He's been nominated as an examiner for BTech and MTech in VJTI, Mumbai. I now hand over to Mr. Kamble. Please.
Thank you, Prasad ji. A warm welcome to all dignitaries and all the audience who are here. So on behalf of the Institution of Engineers, Headquarter, India, and the Institution of Engineers, Navi Mumbai Local Center, and Institution of Marine Engineers, I welcome all the dignitaries for this lecture on webinar on maintenance and operational strategies for mariners. Especially, I welcome Dr. Rear Admiral KWARI Ransingaji, UPSC, PSC, Director General Engineering, Sri Lanka Navy. Welcome, sir. I also welcome Dr. G. Ranganath, Chairman, Committee of Advancement of Technology and Engineering, the Institution of Engineers. Welcome, sir. I also welcome the main person who is a key behind organizing this beautiful webinar. He is a Commander, Dr. Bhaskar M. Bhandarkar, Chairman, Marine Engineering Division Board, IEI. Welcome, Bhandarkar, sir. I also welcome Dr. D. Rajsekhar, Group Director and Chief Scientist, Vessel Management Cell, National Institute of Ocean Technology, Ministry of Earth Sciences, Government of India. Welcome, Rajsekhar, sir. Also, I welcome Dr. Alman Banerjee, Director, Product and Process, HAUS, Centrifuge Technologies. Welcome, Almanji. Also, I welcome Mr. Ilan Fernandez, Vision Author, Marine Technology and Control Systems, Co-Founder, KWAILZ, Education and Training Systems. Welcome, Mr. Ilan Fernandez ji. I welcome the Master of Ceremony,
Right, sir.
Commander Prasad Padyaji, Retired Project Director, Marine Engineering and Shipbuilding. Welcome, Prasad ji. I welcome Mr. V. Lakshmipati Rao, Faculty at HIMT, Visakhapatnam. Welcome, Lakshmipati Rao ji. Also, I welcome all the participants in this program, online, here, or through another link provided by the institution. I also welcome who is coordinating and the person behind the screen in the name of the institution, I think Mr. Kingshu. So I welcome you all. And now, before handing over this mic to our Master of Ceremony, Commander Prasad ji. So before that, it is my duty to introduce Mr. Prasad, Commander Prasad ji, before you. Commander Prasad is a marine engineer with service on system and diesels. During his 24-year service, he has served from the largest to smallest warships of Navy. He has faced fire, flooding, and was awarded a Chief of Naval Staff Commendation for damage control on an aircraft carrier. His short tenures have seen him involved with training the new generation of mariners. He has been responsible for spares and stores supply for Indian as well as Qatari Emiri Navy. He has handled resources and facility management and also quality assurance as a part of inter-supply management chain. He has built warship for the Coast Guard at Mumbai and Goa. So such an respectable personality is Master of Ceremony. So I hand over to Commander Prasad Padheji, please.
So, gentlemen, at the same point in time, I do remain humbled because we have a phenomenal galaxy of marine engineers here today, all under the aegis of the Institution of Engineers India, of the Marine Resources Division. As far as the theme itself is concerned, we are all aware as to the costs involved in running any of our platforms. And I'm not just talking about ships. I'm talking even about all marine platforms that we use, whether it is oil rigs, whether it is lighters, whether it is barges, whatever it is that floats on the water. It involves an investment, and more than investment, it involves the livelihoods of so many people. For this reason, keeping these costs down is paramount. At the same point in time, as the world is changing and going through various technological revelations, wherein we are cutting down manpower because that happens to be our maximum cost area. However, under the circumstances, it really becomes a question as to whether we should be looking after planned preventive maintenance, or we should be undergoing risk-based maintenance, or whether it should be condition-based predictive maintenance, or whether it should be a combination of all these. We also have a phenomenal amount of technology being brought in. We have computers coming in. We have machines thinking for us. However, at the end of the day, we really need to look at which is the best way ahead. And it is with this thought in mind that the Institution of Engineers Marine Division has taken up this challenging task, because, ladies and gentlemen, as you know, manufacturing a ship and thereafter takes its own costs and requires its own resources. But thereafter, keeping that ship, whether that ship remains in commission for the next 15 years or 20 years or even 30 years, it all depends upon the maintenance and operations that we carry out on that particular platform. And as technology advances, we really need to look at which are the areas in which we can take it. So that, ladies and gentlemen, is the theme, that is maintenance and operations of marine platforms. Now, for this, I would be, under normal circumstances, introducing Dr. Bhandarkar just now. However, at his end, he is suddenly having a Wi-Fi connectivity issue, which is precisely what this theme is all about. We can move from our greasy hands and our spanners to huge technology, which will help us with a lot of savings. But how much can you depend upon that technology? Well, ladies and gentlemen, here is a wonderful, fantastic example right in front of you, that the next person who I'm supposed to be introducing you to has a Wi-Fi download problem. And so I will be skipping it slightly and moving on to the next person, that is Dr. G. Ranganath, who's the chairman of CATE. Dr. G. Ranganath, who's the fellow of the Institution of Engineers and a council member of the Institution of Engineers India, is working as the principal Adhyaman College of Engineering, which is an autonomous college at Hosur. He obtained his BE, ME, and his doctorate in engineering disciplines. Dr. Ranganath has more than 35 years of multifaceted interdisciplinary professional experiences and has pioneered about 70, that's 70 research papers. I repeat, 70 research papers and publications, and 10 books on engineering. I'm immediately reminded of B.L. Thareja, and I'm sure I will soon be finding quite a number of people speaking about Dr. Ranganathan. I don't know how many of them will be using it as a pillow. So we have 10 books on engineering and technology. Apart from his academic activities, he is actively involved in societal development through professional bodies, including IEI, ISTE, CSI, etc. In Institution of Engineers India Limited, He has served as a committee member and chairman in Salem Local Center and the Tamil Nadu State Center of the institution. He has also served as a founder chairman, Hosur Local Center, IEI. He has organized a number of national conventions, all India seminars, workshops for the engineering facility. He has organized 32nd Indian Engineering Congress. Now that is really something. The Indian Engineering Congress was at Chennai and it was graced by the Honorable President of India, Mr. Ramnath Kovind. He has served as National Vice President and is presently the Chairman, Committee for the Advancement of Technology and Engineering, that is CATE. He is a council member in ISTE and is also serving as a syndicate member in Anna University. As you can see, ladies and gentlemen, quite an impressive lineup of research papers, quite an impressive list of books, and quite an impressive list of social activity that Dr. Ranganathan has taken up. May I now request Dr. Ranganathan?
Thank you, Commander Prasad Pateji. I am so happy and thankful for you for a wonderful introduction of me. I don't know how far I am worthy towards it with your love and affection. And in absentia, the President of IAI, Thackerayji, and good friend of me, Chairman of Marine Division Board of IAI, and we can call him as an elderly personality in the Marine Division, or the elderly personality in the Marine Division, Commander Dr. Bhaskar Bhandarkarji, the Navi Mumbai Local Chapter Chairman, who is served for the center long back, the VC Kombleji, and the most important guest of today, to be called a chief guest, Dr. Admiral Kauri Ranasingheji, who is all the way joining us from Sri Lanka. The panelist, Engineer Amal Banerjee, E.A. Fernandez ji, and Lakshmipati Rao ji, and Dr. Rajshekhar ji, who is going to act as a moderator for all these things, and all the participants for this wonderful program. Good evening to all of you. First and foremost, I want to congratulate Commander Bhaskar Bhandarkarji. He is an elder in age, but youngster to all the youngsters in dynamic activities. How he is taking to forward, what the interest and love and affection he is having in the organization of IEI. Why I am using these words, one may feel a little surprised. I am there in the council from past couple of years. I have seen a lot of divisional board chairmen from the various divisions, what type of interest they are showing, how they are driving by themselves to take forward the activities of IEI. For past 1 year, even 1 year not completed, only 9 months completed. I was so happy. Congratulate Commander Bhaskar Bhandarkarji through my heart. I used to call him his elder brother because his nature of age. Otherwise also, I am so happy to call him as elder brother in taking IE activities in a fantastic way, and especially to be called one of the smallest division of IEI, Maritime. Today, activities has become biggest division of IEI with activities concerned. Apart from activities, the way how he is mobilizing the speakers, those are all international repute. Those who are from overseas, I am openly endorsing, which never happened from long years, from past years in many divisions. And it never dreamt in even particularly Marine Division. Today, Marine Division, I can say, not only as a CATA chairman, as a corporate member of IEI, as a council member of IEI, I can say today, Marine Division has become most active part in IEI in seeing biggest personalities across the globe. Through bottom of my heart, I am congratulating Bhaskar Bhandarkarji. Then coming to this today's topic, certainly, I don't know how far I am competent to talk this topic because eminent panelists, eminent speakers, beyond these two, the most important chief guest from Sri Lanka, who is the Navy's chief, Kauri Ranasingheji, who is an admiral, is going to say something on that. So if I am going to say something on marine, which is not going to be matching for your expectations, You may feel little uncomfortable, but don't worry. I will not feel you uncomfortable. But I can say commonly, generally the maintenance of ships is most important. What for? To avoid the cost of use cost for replacement when it is not going to properly maintain. What I feel personally. Then always good maintenance will always give a long life for the ship. So unless otherwise you maintain properly the ship, it will not have a long life. It's quite natural. If you don't maintain our own body properly, then we cannot see either 60 years or 80 years or 100 years, as we say. Similarly, any equipment, any machinery is there, but ship is totally different than other things. And it is important. So it maintenance is most important. Then the cost of maintenance generally is very less compared to loss due to safety issues, loss due to environmental damages, loss due to maybe unreliable operations, and so on. So unless otherwise you maintain properly the ship, there will be safety issues will rise, environmental damages will concern, and operational cost will be different. So it has to maintain properly. Then we come to the strategy for planning for this. High maintenance is always correlated with performance of the ship. So with these small inputs of my feelings, I am very, very happy to congratulate. But here I want to say one thing to, especially the panelist, Lakshmipati Rao, who is going to consolidate the job at the end of the program by thanking. Since he is in a faculty like me, I am a faculty in engineering college, he is a faculty in Maritime institutions. My appeal to Lakshmipati Rao ji, I want to tell to you, you know very well, IA is century-old institution. 2020, we already celebrated century year because it is way back 1920, it is started. And there are 15 divisions, your marine division is another division. But the size of this division, marine, is very, very small. If Lakshmipati come forward in understanding our marine division, every year, when the students are going to be graduated from his organization, he can educate them, motivate them, inspire them to become members of this forum of IEI. Because as and today, depends upon the size of the IEI corporate members in Marine Division, there are only one council. When an election has happened last year, that's 2021, the only one council member you are all elected is Bhandarkarji. In 2025, again election is going to happen. So before March of 2025, I want to see this membership is going to be increased considerably so that there will be at least 2 council members in the region of Marine.
I know, sir.
I'm there.
Got it.
I want to endorse, I want to see one more Bhandarkarji in the council as a council member by getting 2 council seats in the council of Marine. This is my appeal to Lakshmipati Rao ji with my heart. It's not that something I'm telling to you. Please do come forward to join this forum of IEI. This is a prestigious forum for engineers in the country. We all join together. Let us do together. Let us make that things together, because all our young engineers, budding engineers are expecting a lot, to learn a lot. So today, this program is going to give a lot of inputs to all the participants. Dear participants, enjoy the speakers by listening them, by having interaction with them when they give opportunity for you. With this, let me thank Bhaskar Bhandarkarji. Let me thank our Prasad Pandeyji. And let me thank all the corporate members who joined this forum of IEI for this wonderful program. And let me thank our chief guest who joined us from Sri Lanka. Sir, we are very, very happy to welcome you on behalf of IEI headquarters of India.
Thank you, Doctor. Thank you, Doctor.
Thank you all.
So, ladies and gentlemen, as we proceed, luckily so, we now have Dr. Bhandarkar back on track. So allow me to introduce the person about whom Dr. Ranganathan has spoken so finely. Commander Dr. B.M. Bhandarkar is the chairman of the Marine Division and a multifaceted personality, as we've just heard from Dr. Ranganathan. He has been an engineer officer on board INS Chakra, that is India's first nuclear submarine, which is operated by the Indian Navy. He is credited with the national record of winning the Prime Minister's trophy for the most enterprising unit for 3 consecutive years. He was the commissioning officer in charge of the Kursura Submarine Museum. Gentlemen, so here we have a totally different dimension of marine engineering. We keep speaking about the blacktop area of all our ships, wherein the air and the water mix. Here we have an officer who goes underwater and operates in the calmness of that environment. He's been the commissioning officer in charge of Kursura Submarine Museum. He set it up. It is a unique engineering marvel. It is something which is there in Visakhapatnam, and may I sincerely recommend that whenever you go to the city, please go to the beach and look at how a submarine looks like. This is all thanks to Dr. Bhandarkar that we see it over there today. He has been commended by the Flag Officer Commanding in Chief of the Eastern Naval Command not once, but twice for his professional acumen, dedication, and achievements. Why is it that we don't find it surprising, sir? Dr. Bhandarkar has been actively associated with many professional and social institutions and was the National Council Chairman of the Indian Institution of Industrial Engineering. He has been the governing member of the Engineering Council of India. He is also a board member of the Asia Pacific Industrial Engineering and Management Society of Japan, and he is a fellow of IEOM USA. He has been awarded by the Coal India Productivity Award, the Lillian Gilbert Award, Ramaswamy Award, Jewel of India Award by Indian Solidarity Council, Shiksha Bharati Puraskar by All India Achievers Foundation, Best Educationalist Award by International Institute of Education and Management, Indian Achievers Award for Education Excellence, Ramaswamy Cup for significant contribution to industrial engineering, and Shiksha Bharati Award by Indian Achievers Forum. Ladies and gentlemen, this is what I have about Dr. Bhandarkar after cutting through 2 pages of what I actually should be speaking about him. The officer has a phenomenal list of other achievements also, but he is humble enough just to list out the topmost ones among them. Over to you, Commander Dr. Bhandarkar.
Thank you, Commander Prasad. Honorable Chief Guest, Dr. Rear Admiral Ravindra Ransinge, Uttam Seva Parakram Padak, PSC, Director General Engineering, Sri Lanka Navy. He has devoted decades of quality life to promoting excellence in marine engineering. Our friend, philosopher and guide, Dr. G. Ranganathan Ji, the visionary academician, quality crusader, and the chairman of Committee of Advancement of Technology and Engineering, whose sagacity is driving technical division, Institution of Engineers to greater heights. Dr. D. Rajsekhar, the visionary chief scientist from NIOT Chennai, a dedicated researcher and a distinguished mariner. He also served in Coast Guard for many years. Engineer Amlan Banerjee, the acclaimed mariner and director at House Centrifuge International. Engineer Elstan Fernandez, the prolific author of technology books, many of them, and the much-loved trainer. Engineer V.C. Kamblesa, the dynamic secretary of Maharashtra State Center Institute of Engineers and former chairman Navi Mumbai Local Center, whose quality case is ushering new dimension of excellence in the metro project of MMRDA. Commander Prasad Pandey, the young, adorable project director from Marman Engineering and Shipbuilding, Goa. Engineer V. Lakshmipati Rao, faculty HMIT Visakhapatnam, co-convener 31st National Convention of Marine Engineers, respected members of MRDB, Dr. Sadhanji Ray, our council member from Textile Division, members of Institution of Marine Engineering and Institute of Engineers, participants, media, dear students, our enterprising and dedicated technical division staff from IEI headquarters, ladies and gentlemen. It gives me immense pleasure to extend my best wishes to all the participants of the most relevant and happening webinar. Nearly 9 some disturbance. Nearly 90% of the for any industry, profitability is the prime importance to sustain its operations. Productivity is the key aspects of profitability. Productivity depends on the good and perfect planning. Strategy drives the planning. The reliability and availability of resources form the backbone of strategy. Thus, there is an ever-increasing need for synergy in maintenance and operations of vessels and shore support system. In the maritime sector, many technologies are being used to achieve to the resilience of operations. The diligence in maintenance and operation strategies with a holistic approach would emerge as most responsive way of keeping fleet available for operations at lesser cost and lesser collateral damages. Marine Engineering Division MRDB, Institution of Engineers, under the visionary leadership of Dr. Hemantji Thackeray, President of Institution of Engineers, and Dr. G. Ranganathji, the Chairman of Committee on Technology and Engineering. In its efforts to promote excellence in maritime domain, yeah. Hello.
So
Yes. Okay. Okay. Marine Engineering Institute of Engineers. In its efforts to promote excellence in maritime domain, has facilitated the availability of distinguished international personalities with huge experience and technical knowledge to share their vision on these important issues. I am confident that the participant will be immensely benefited from deliberations in this webinar. I wish you a great take-home content. Thank you. Shano Varuna, Jai Hind, Jai Institution of Engineers. Ladies and gentlemen, because of some technical problem, our master of ceremony is not available now. He may join later. So I will have to do the honor of conducting this show as an emergency measure. Let me see what are the data. I was so confident of my friend Commander Prasad that not much of the data is available with me, but notwithstanding that, with all available information, I will try to take
Sir,
this
I'm
to-
back. Sir, I'm back.
Okay. Good. Thank you. Go ahead.
My apologies for the hiatus, ladies and gentlemen. It now falls upon me to introduce Dr. Rear Admiral KWARI Ranasinghe, Uttam Seva Padakam of the Sri Lankan Navy. He is the Director General Engineering of the Sri Lankan Navy. Admiral KWARI Ranasinghe of the Sri Lankan Navy was commissioned on the 15th of September 91, and he has undertaken the training at INS Shivaji Lonavala, close to Bombay, where he has done his basic engineering course in the Naval College of Engineering. Incidentally, this also happens to be the place where I have done my marine engineering, as well as what Dr. Bhandarkar has done. He's gone into submarines, I've gone into aircraft carriers, and Admiral Ranasinghe here has gone all over the world. And as you can see, he has a BTech in mechanical engineering, followed by which he has undertaken the marine engineering specialization course at the Center of Marine Engineering Technology at INS Shivaji Lonavala. He was awarded his engine room watchkeeping competency by the commander of the Navy after successful training on board Sri Lankan naval ship Abhitha. Ladies and gentlemen, for those of you, the first ship which you go on is something that remains with you for the rest of your life. And I'm sure the Admiral must be thinking about that particular ship with real fondness. Admiral Ranasinghe has followed a large number of career development training in India, Singapore, USA, Israel, Germany, and the Netherlands. He has followed postgraduate diploma program on maintenance management at NIBM in 2003 to 2004. He has undertaken Defense Services Command and Staff College at Malaysia, and he was awarded the postgraduate diploma on strategic and defense studies by the University of Malaysia, or University of Malaya, in the year 2006. He has also completed an MBA in technology management at the University of Moratuwa from the year 2011 to 2013, and a course on human resources management at Sri Lankan Institute of Development Administration. Considering his academic and professional qualifications as well as experience, he has been awarded with the Doctor of Business Administration by the American National Business University in 2022. He has had vital key staff and command appointments in the Sri Lankan Navy, including Commodore Superintendent Dockyard West, Dockyard North, and Dockyard North Central. He has been Deputy Director in the Marine Engineering Division. He has been Director, Engineering Services, and Director, Marine Engineering also. Admiral Ranasinghe was promoted to his present rank on the 20th of April 2018 and is presently holding appointment as Director General Engineering of the Marine Engineering Branch, which has 440 engineers with 8,500 workforce, and performing as the principal advisor to the Commander of the Sri Lankan Navy on engineering matters and the need for Marine Engineering Branch. He is a recipient of the Uttam Seva Padakam for meritorious and distinguished service. He is also a recipient of the Purna Bhumi Padakam, Riviresa Campaign Service Medal, Vadamarachi Operational Medal, Sri Lankan Armed Services Long Service Medal, 50th Independence Anniversary Commendation Medal, Sri Lankan Navy 50th Anniversary Medal, North and East Operational Medal, North and East Humanitarian Medal, and Commendation Badge from the Commander of the Navy. Admiral Ranasinghe is a distinguished fellow member of the Institute of Engineers, Sri Lanka, Institution of Engineers, India, Institute of Marine Engineering, Science and Technology, UK. He is also a chartered engineer in Sri Lanka, India, and UK. As you can see, ladies and gentlemen, we have quite a phenomenal achievement in a singular person. May I now request Dr. Admiral KWARI Ranasinghe to kindly do us the honors and address the gathering. Admiral Ranasinghe.
Thank you, Doctor. Thank you so much for such a nice wordings to introduce me. And Ladies and gentlemen, it is indeed a great pleasure for this opportunity to receive this kind of an opportunity to attend such an event of this magnitude as the chief guest to deliver the Sri Lanka Navy's wisdom on the subject on maintenance and operational strategies for the mariners through the technical webinar hosted by the Institute of Engineers India, organized by the, I made to understand that it is organized by the Belapur local center under the Aegis of Marine Engineering Division Board. Gentlemen, it is basically a really a joyful to be the chief guest of magnitude, an event of this kind of a magnitude. But when it is an event which is basically participated by the engineers, yes, your joy is doubled or your thrill is doubled. And then when it is the event basically full of the engineers from India, the joy is tripled or maybe much more than that. Because as you all know that India, I consider it as my second home. It is the Indian Navy which laid the foundation of engineering into me, and my career started, and I spent almost about 5 to 6 years of my best period of my life in India, from the age of 19 to 25. So thanks again for inviting me, and indeed I'm quite grateful to Dr. H.O. Thakare, the president of the Institute of Engineers India, then the Commander B.M. Bandarkar, chairman of the Marine Engineering Division Board, and Mr. Kane Godbole, the chairman of the Belapur Local Center, and also Dr. G. Ranganath, the chairman of the CATE IAI, for the nice words he spelled about me. Thank you very much for everything. Now, with reference to the proceedings of the webinar, it is well incumbent fact to understand that we have an august and competent panel of speakers to talk on the topic, which gives me an immense pleasure to get this as the chief guest. In fact, we have a well-renowned moderator for today's event, Dr. Rajesh Kar, the chief scientist from the National Institute of Ocean Technology, the Ministry of Earth Science in India. Gentlemen, I am confident that today's sessions will penetrate through the sound skills and oak intellects of the mariners attending this webinar to elevate the thinking philosophies on maintenance and operational strategies. So I will be speaking on following topics for the next 20 minutes or so. So the aim of my presentation is selecting maintenance and operational strategy as the best trade-off for a mariner, and introduce the means of analyzing risk potentially affecting the maintenance interventions associated with the chosen strategy and how to rank them according to the priority. We all know that the mariners, one of the biggest challenge as the marine engineers, the biggest challenge we have is you have to trade off between, there are few very important factors. One is the most important factor is the operation reliability, the cost, the availability. The reliability, of course, cannot be compromised at any level. But then we cannot forget about the cost as well as the operational availability of the assets we have in the marine engineering environment. So it is our duty to select the best maintenance strategy for our organization, so that the organization will benefit as well as we as the individual will benefit. If you are going for if you do not achieve the correct balance between these three factors, then you are basically will become a ridden of character, because it is you who made the decisions which will give the ultimate results. So it is, I think, we need to understand what is the maintenance. I think all of us know this one, but anyway, I just put it because it is a customary thing. The British standards, the 13th 306 of 2010, It defines the maintenance as the combination of technical and organizational activities aimed at guaranteeing the system's functioning during their whole life cycle, in terms of retaining them in or restoring them to a system in which they can perform their required task. So, gentlemen, as I mentioned you, the selection of maintenance strategy, the decision-making problem, there's framework is the framework supporting the maintenance strategy selection problem. So there are conditions of analysis: the certainty, risk, and the uncertainty. So certainty is basically supporting tool is the there are various supporting tools like graphical models, and for the risk, it's some mathematical models, simulations, artificial intelligence, heuristic models, hazard analysis, and then the MCDM models. I'll be talking about them in the coming slides. This is the framework basically used in the literature for the problem of maintenance strategy, selected in diverse condition of the analysis. We were all, I think the Commander Prasad also mentioned that there is a kind of reactive maintenance, or we call it breakdown maintenance, or then there's a preservative maintenance, or the planned preventive maintenance, then the condition-based maintenance, or the opportunistic maintenance. So these are all like, if you take a machinery, these conditions like the safety and security, the cost, reliability, availability, the feasibility, then the added values, all these things are considered. And when we evaluate our maintenance strategy with these factors, you will realize that one cannot basically adhere to one particular maintenance strategy. You will see that there is so much of overlapping between these factors. So it is up to us, the marine engineers, that we should analyze them very carefully and then select the best maintenance strategy for the combination of the maintenance strategies actually that is required for our maintenance system. So I'm not going to talk about them. I think all of us know this one. I think it is basically, I consider it as a humiliation to talk about these basic things in this kind of a gathering. But I just put it there so that it will give you, it will refresh your mind. So there are basically three: that corrective maintenance, preventive maintenance, and the predictive maintenance, which is the newest addition. It's not newest, of course, but that's going to be the trend in the future. So these are basically, again, the basics of the corrective maintenance, the advantages, disadvantages. In terms of preventive maintenance, or where we call it the planned preventive maintenance, there are a lot of advantages, but then there are disadvantages as well. The investment is too much. We're spending too much of money on the maintenance. That is one of the biggest disadvantage in this system, but it gives you a better reliability also. And the newest addition, that is the condition-based maintenance. There are so much of advantages in this one. Only the disadvantage here, we have the high upfront cost, including the equipment and the training. The training here is a very, very important factor, though sometimes we tend to talk about the cost involved in the acquisition of the technology and the machineries or the equipments that are used for the condition-based maintenance. But ladies and gentlemen, the amount of money that we have to spend on the training is a big challenge. It's a huge cost. But the other challenge is the retaining of these talents. Once you train them, these people are in a very high demand outside the world. So it is very challenging to retain these highly trained or the highly skilled people, because you can't train large number of them because of the cost. So you have to have very limited number of trained people used in this kind of a maintenance technology. So why the condition based? I think all of you know that being in the marine engineering field, that lot of talk are going on about the CBM, the maintenance cost reduced by 50%. This is the analysis by the Department of Defense, USA, in 2008. The unexpected failures reduced by 55%. The repairs and overhaul time reduced by 50%. The spare part inventory reduced by 30%. That's huge margin, 30% of inventory. The meantime, MTBF increased by 30%, and the machinery availability increased by 30%. I hope you all can remember that I talked about the three factors. One is the availability, the operational availability of your machinery. So you see that the impact this condition-based monitoring maintenance systems can have on our system. And our technicians, they can perform the maintenance act within the very precise repair planning. It has many advantages. As I explained you, apart from the capital cost, there are so many advantages. The United States Department of Defense, they started this program somewhere in 1986. And I know that the Indian Navy, I'm not sure about the other engineering institute in India, but I know that the Indian Navy started it somewhere in 1990s, early 90s, and it's still going on. And we, followed by, we always consider the Indian Navy as our guru, our teacher. And we also started this somewhere about 10 years back, and we have grown quite a number of distance in this regard with the help of the Indian Navy. Some of you may aware that this Department of Defense website of the US, it gives a complete literature on this subject, and they are now in a program called the CBM Plus program that is going beyond the CBM. They are sometimes they call it as the reliability centered maintenance. It's kind of a proactive maintenance. I'm sure that you all know this one. The performance against the time curve of the machinery life. This is two generic curve for a very, very simple machine. I just wanted to explain you the concept, the real. But if you take the real curve, it is going to be a very complex. So the smooth operation during the time to failure, the first sign of trouble, up to the first sign of trouble, then you will get a kind of a warning time before your failure. So this is where we have to act. This is where we need to identify. Then we will have a better maintenance plan. Now, gentlemen, I hope you can remember that I said that we need to have a mix of maintenance policies during the lifetime of the particular machinery. So though we prefer to have our own system, sometimes we are compelled to do this only. Just say the warranty coverage, the warranty period. The OEM, the original equipment manufacturer, will agree with us that they will allow us to perform the condition-based maintenance in their machinery during the warranty period. They will straight away say that no, we will not give you the warranty coverage. So we are compelled to, because you may know, all of us know that the critical failures can occur in the warranty period. Some of the manufacturing defects can appear. So no, not that any machinery is 100% foolproof. So there are issues. So I don't think any of the organization in the world, they want to accept that kind of a risk. So they prefer to go with the PPM or the manufacturer indicated training, the maintenance program during the warranty coverage. Then the TBM, the type-based maintenance, and then comes this Synthesize.net. This is the where you have to be very careful. This is where you can apply your conditions-based maintenance practices before the failure. But you have to identify the failure before it occurs so that your machinery is reliable. You will avoid the damage. You will save a lot of cost by identifying this one. We have had a lot of experience, and I am really grateful for our fellows who has identified large failures. One of the major example, I would say that we call it Suraksha. It was basic. This ship was handed over from the Indian Coast Guard to us somewhere in 2017. Old ships, but the engines, of course, it's an OPV. The cost of two engines, maybe about Sri Lankan rupees 1 billion. I'm sure it is somewhere around that one. Our team could identify the giving away of copper to the lubrication oils, and our team could identify that the main bearings are slowly giving away. So the timely action prevented major breakdown and saved a lot of money or the disaster for the Sri Lanka Navy. This is some of the typical PF curve for a mariner to look for. The first half is basically, we call it the predictive domain, and the second half is the fault domain. You see that at the initial stage, when the defects start occur, the human we can't just identify them. We have to have this specific equipments to identify these defects. Some of them, the earliest stage where we can identify the defects are basically using the ultrasound technology. Then the oil analysis, as I explained you on board one of our ships, that the experience we got in. Then the vibration. Then the infrared. Infrared will give you the identification signs for determining your defects. Then it is going to the fault domain. Okay, you will get audible noise, then you will get the hot, you can't touch them, and if you don't care it, or if you don't take any preventive action, then your machinery is gone. This is the curve that I wanted to explain. I'm sure that many of you must have studied this one or gone through this one. So these are some of the maintenance strategies that are followed in the Sri Lanka Navy, and I'm sure the Indian Navy is having much better or the much advanced techniques than this solution. We are using vibration analysis to the greatest extent.
Sir, can you ask that person who's handling the PPT?
Then the ultrasonic noise analysis. Then oil wear down analysis, oil testing, diesel engine compression testing, thermography, as well as the non-destructive testing. Right. So, gentlemen, these are basically, we believe that it will give us a total CBM solution. The combination of this will give us these techniques will give us a total CBM solution. So these are some of the photographs that we are using, we have taken during the maintenance activities by our technicians or our sailors. Then we have to identify the KPIs, so the key performance index of this. That's how we have to analyze this one. The Pareto principle, all of us know that the 80-20 rule. So what this is, roughly 80% of the effects come from 20% of the causes. So this is where we have to be very careful. We have to identify the 20% of these causes so that we can prevent 80% of the defects. This is the analysis that we are using. Basically, we have done the failure mode criticality analysis. It says these are the factors basically. What machinery controls, what are the tools available, what are the correct methodologies. Then are we professionally competent enough to do it? What else is required for final recommendation? Any outsourcing? Maybe sometimes we don't have the required expertise to analyze it. Though we have taken the data, we cannot analyze it. Then we may have to outsource it. That is one of the example. Then what is the Sri Lanka Navy operational requirement or the criticality of the particular machinery? Will the recommendations be viable or effective? Sometimes you may have the best of the recommendation, but it is not viable. So sometimes it's not effective. These are also the factors that we are thinking of. Then will our top management assist the implementation of such a program or such a recommendation? Then we have given the KPI values for all this FMCA index, and then we have to decide on our the maintenance strategy. You always have to consider the KPI value of the FMCA with the KPI value of 10. They are the most critical items. So the reliability centered maintenance methodology is based on the failure mode and effect analysis of the items involved and is focused on preventing system functions instead of preserving the asset itself. Reliability centered maintenance is a qualitative approach in order to design an efficient management plan. This is the criticality matrix that we are using. The term functional decomposition, sorry for my mistake, gentlemen. The functional decomposition in the maintenance modeling is a very unique word. The famous hamburger model. You know, there are various maintenance models, but here we have to be very careful that different models may come, but they will not become straight away become concepts. These models will have to be used in prove in time and time again and again for that to become a concept or maintenance concept. So these are some, just talking about some of the models. So, but they are not a maintenance strategy. So we have to understand the difference between these two. So the hamburger model uses this terminology to split each function with critical activities listed to give further criticality analysis to function. It elaborates the function, the functional specification, and function solutions are visualized, and by categorizing the criticality, criticality means very critical, critical, less critical, or not critical, then the importance of each function in the system can be weighted. This is one of the examples of transporting water I have given you. So, gentlemen, what actions are to be performed in determining a maintenance model based on the functional critical RCM, or reliability centered maintenance? FCRCM, the functional critical RCM. It is basically system selection for collecting system information. Then determine the system boundaries, what is in the system and what is not. Determine system functions, descriptions, functional block diagram, and decomposition. And then determine the functions, functional specification, and functional failures. And then determine the functional critical failure model and effect analysis. Perform the functional consequences analysis, FCA, and risk management metrics for critical and very critical components. Perform maintenance task selection and determine the maintenance plan. This model was basically talked about Mr. Lasaki and et al. And the others in their paper titled Effective Ship Maintenance Strategy Using a Risk and Critically Based Approach. So this is a sample for FMEA that could be used in the organizational maintenance activity as shown in the screen. The respective column of the information are used in getting the data for identifying failure modes, and the effects, identifying the causes of FMEs, the priority, determination of corrective actions with the risk priority number or RPN. We assign an RPN, and then we take the decisions accordingly. These are the FMEA inputs and the outputs. Inputs are basically the process matrix, process map, history, procedures, knowledge, experience, and then outputs are basically list of actions to prevent the causes of detect failure modes. History of actions taken, that we have to maintain the history of actions that we have taken. So what would be the process element in the FMEA procedure? I'm not going to reach each and every of them. So for each process input, start with the high value inputs, then determine the ways in which the input can go wrong. It is the failure mode. For each failure mode, determine the effects. Select the severity level of the each effect. Maybe you can assign a number between 1 to 10 to indicate the severity. Then they identify the potential causes of each failure mode. Select an occurrence level for each cause. If it is very high, maybe again 1 to 10. Very high, it is 10. Or if it is less, 1. Then the list the current controls for each cause. Select the detection level for each cause. Calculate the risk priority number, RPM, severity, occurrence, and detection. That will give you the multiplication of these factors, will give us the RPM. And then develop recommended actions, assign responsible persons, and take actions. Give priority, high RPMs, and must look at the severity rated at the 10. So these are the things that I wanted to highlight in this process. So what is an ideal management system or the ideal maintenance management system for a mariner? That is the challenge we have, and I'm sure this is the particular model that developed to help us in identifying the most effective maintenance management system suitable for us. The availability, I think these factors we have already discussed. But when it comes to availability, the reliability, the maintainability, and the supportability. In the reliability, it's a failure analysis and the RCM and Fmea. The maintainability, then the supportability, it is the maintenance staff, asset management system. Then you have a maintenance program, plant facility operations, asset manufacturing and installation, and the design, and then the defect elimination. That is the most critical thing. Then staff thing, the core team, the maintenance rules, analytical reports, and the long range plan are the some of the most critical scenarios or the phenomenon of this concept. Especially your team is very, very important in this concept. Just an example to explain. If your technician is taking a vibration reading, even a small change of angle might give you a wrong interpretation. So it is very important and critical that we use a very, very highly trained technicians and engineers for this kind of a task, because your reliability depends on the actions they are taking. So managing ship maintenance operations, these are the things that protect your assets, schedule the routine preventive maintenance, improve your inspection process. These are the ultimate goals that we have to do. The optimize the inventory management system and track the operations data through electronic report. And the active redundancy is an important factor. It is a concept that increases the operational availability and reduce the operating cost by automating most critical maintenance action. There are 3 actions involved in this one. That is the fault detection, fault isolation, and the reconfiguration. And last but not the least, the E-management system or the computerized maintenance management system is critical for the current or the modern world, an engineering organization in the modern world. It will give us the structured maintenance data and very efficient internal workflows, reduce downtime, expanded lifetime, maintaining knowledge, full inventory control, improved working environment, secure data exchange between vessels onshore and when in the dry docks. For your information, in Sri Lanka Navy, we have already started the computerized maintenance management system in the our biggest ship repair facility in the Eastern Naval Area in the Trincomalee. So in conclusion, I would say that the shipboard maintenance is an art. So all of us are the key actors in this scenario. So finding an optimum solution, pivoting the organization is a must. So as I was emphasizing in many points in this presentation, we have to find our best solution. No one else can give you. We are the people who know the organization. We are the people who know our machinery, and it is up to us to identify the best maintenance solution for us. Then the skilled manpower, I was emphasizing on it many times, an advantage. But I don't say that it's an advantage. It's a must in maintenance strategy, development activities. The extended CBM and RCMs gives a mariner a variety of maintenance options. The e-maintenance, as I told you, the computerized maintenance adds more freedom of actions for the maintenance. I think this is what I wanted to highlight. So I'm sure many of the things that were included in this presentation is not new to many of you, because all of you are, pioneers in this industry. But I hope that I have done a justice by sharing my views on this one, this particular aspect or this particular subject with you. And once again, thank you very much for inviting me to be the chief guest of this August gathering and the event. Thank you so much.
That was, ladies and gentlemen, that was Dr. Rear Admiral KWARI Rana Singh. Leading 25 minutes, the Admiral has put in his entire efforts into running us through the entire lot of plant preventive maintenance, computer-based maintenance, NDT, IR, noise and vibration signatures, ultrasound, fluids analysis. The Admiral spoke of mixing of the maintenance plans and the productive fault curves. He spoke about KPIs. He spoke about the hamburger model. He spoke about functional critical reliability maintenance. In short, ladies and gentlemen, the Admiral has run us through the entire gamut within the past so many few minutes, and he encapsulated everything by his final talk, which I'm sure can be a tagline for all of us. And what was that tagline which the Admiral gave? It is that finally everything is up to us. You got 6 lovely letters, up to us. So you have the technology, you have the various training, etc. But finally, it is up to us. Thank you so much, Dr. Admiral Rana Singh, for your wise words and encapsulating everything so briefly. Thank you very much, sir. So, ladies and gentlemen, from here, we move on to the remainder of our topic. And now I take you on to introduction of the moderator for today's talk, that is Dr. D. Rajshekhar. Dr. D. Rajshekhar is the Group Director and Chief Scientist of the Vessel Management Cell, National Institute of Ocean Technology, Ministry of Earth Sciences, Government of India. He has been a BE Mechanical Engineering from Osmania University. He has done his MS from IIT Madras and his Marine Engineering specialization. His doctorate is in the Mechanical Engineering field. Dr. Rajshekhar has an illustrious career of having been a Chief Engineer Officer on the Indian Coast Guard of the Ministry of Defense for a total of 8 years. He has thereafter been a Chief Engineer in the Merchant Navy and various shipyards for a further 6 years. So there you have it. He's been in the government wearing a uniform. Thereafter, he's been in corporate. Thereafter, he has been the chief scientist and group director of vessel management cell at NIOT Chennai from 2002 till date. And he has more than 35 years of experience in marine engineering and the maritime industry. The doctor has 45, I repeat, 45 technical papers. He has 2 book chapters, 15 proceedings, and 5 patents. Hats off to you, Dr. Rajshekhar. And now I hand over to our very own doctorate with 5 patents, and I do hope it becomes more as the years pass on. Dr. Raj.
Good evening, everybody. Thank you, Commander Prasad. It was a nice introduction. Happy to be listening, but I'm not too sure how much of value addition I'm doing to the society and to my organization and to everybody. But yes, I keep trying. I selflessly, and I see that knowledge is transferred to the younger generation or contemporaries and to the society at large. Anyway, thank you very much. And at the very outset, respected Admiral Dr. Ranasinghe, Dr. Bhandarkar, who is also my close friend, though I have not met him so far. Dr. Ranganath, I think Dr. Thackeray is not here, but with due respects to him. Mr. Fernandez, Mr. Kamble, Mr. Lakshmipati Rao, Mr. Amlan Banerjee, and other dignitaries of the forum. And I can see a lot of students or scholars or marine engineers or engineers are also participating, and welcoming all. It's very nice to be here. I think I must commend Dr. Bhandarkar for the initiatives rather. He keeps on making something or the other and trying to see that younger generation is helped in whatever way he could do. And I'm very happy that I'm able to contribute little bit to the efforts of Dr. Bhandarkar. So coming to the actual topic, with the due thanks to Commander Prasad, he actually summed up the theme quite well. And later the address by Mr. Kamble and of course by the chief guest is fantastic. And the chief guest has covered every aspect, and it's very refreshing to go back to basics and try to sort of implement or incorporate those basics into practical engineering. Yes, I do understand it. Many times it's not so easy to correlate practice with the theory. Yes, it's a fact. But I think the theory helps us in trying to derive the right practice, which I'm sure everybody is aware. And I have seen my own friends, seniors, juniors, trying to do this. Or if somebody is not doing, some other person is advising them. So overall, I think this application of theory to the practice is generally going well, though there is a scope for a lot of improvement. I think a lot of, there are, with respect to the maintenance strategies, Admiral has mentioned many things, and which are really good, and it's very refreshing to everybody. But I would like to say one important aspect, besides the cost control and time control and achieving the desired quality. These three, of course, these are the standard things that for any maintenance strategy or for any operation strategy, these are the these are the basic things that needs to be done. But besides this, I think innovation matters a lot, especially with new technology coming in and new policies coming in, and with entire data available on a small screen of a computer. I think innovation is extremely important, especially for the marine engineer. And by following the traditional methods with respect to maintenance, I think we need to sort of push ourselves into understanding why a particular procedure is adopted, by understanding the reasons, which means a bit of research, a bit of homework on the particular method, which will probably enlighten much better, and it will also help deriving a much better maintenance strategy. For example, take the hot topic of green technology. Okay, most of the merchant ships, I'm not considering the defense ships where they use the low sulfur high speed diesel, but most of the merchant ships, they use the crude oil, which requires a lot of filtration, and of course for the reasons of economy. If they use a low sulfur diesel oil, yes, green technology to some extent we can achieve, but that's going to be expensive. So it is important to innovate something without changing much of the existing engineering procedures. I think that's where the innovation comes into picture. And earlier, say 15 years back, ships needed to be dry docked for any underwater damage or anything. But there are cases where in India and abroad, globally, it's done that, using CAFA dam technology at the harbor in rough seas, these underwater damages were repaired by using a dry welding. Though underwater welding is available, but underwater welding has its limitations. So, I mean, the marine engineer has to be innovative in trying to establish a proper strategy and to achieve a proper cost control and also time control with the desired quality. I think this kind of thing is very, very important, and it needs to be addressed by the students of marine engineering or mechanical engineering and the faculty and the people who are serving. It's very important. And lastly, one small thing: whatever technical advancement or whatever technical achievement is done by any marine engineer needs to be converted as a small technical paper. So, I mean, somebody thinks why a technical paper is required. For one simple reason, that helps others. So overall, the whole community of marine engineers can read it, can go through, can improvise, can sort of innovate further, and it helps in the quality of the work. It also helps the enhancement of the knowledge. I think these are the things which are very important. So I mean, I'm sure all of you agree to this, and I'm sure the students or scholars or professionals make note of this and follow this. With this, I think I thank you again, everybody, and thank you very much for giving me this an opportunity. Thank you. I think next in line is Kamala Prasad. You would like to take over, or?
Sir, you will be introducing the panelist one, Mr. Amlan Banerjee, and followed by his address. You'll be introducing Mr. Elsan Fernandez, and after his address, I'll be taking over. Sir.
Okay, thank you. Thank you, Commander Prasad. So thanks again to Commander Bandarkar and Institute of Engineers, Marine Engineers Division for giving me an opportunity to introduce one of the finest engineers, Mr. Amlan Banerjee. I will briefly introduce about him, and he is graduate from DMET in 1977 and worked on board ocean-going ships till 1993 as a chief engineer. And also he worked for Westphalia Separators, India, and retired as a director from the same company. And from 2019, he is associated with House Centrifuge Technology, which is one of the finest technologies available. Be talking about the centrifuges, which is the heart of the ship. And thank you very much, sir. And I would invite you to speak on this. This is very interesting, and this will be helpful to the audience and even to us. Thank you. Please take over, sir. Mr. Amlan Banerjee.
Okay. Thank you, sir, Mr. Rajshekar. It is a privilege to be here. This is the first time I'm addressing forum from the Institution of Engineers. I am really indebted to them because if not anything else, I am getting a chance to listen to very many eminent personalities and their thoughts. So before I start, my respects to the eminent people gathered over here, Admiral Rana Singhe, Commander Bandatkar, Commander Prasad, Dr. Ranganathan, Dr. Rajashekar, Mr. Kamble, Mr. Lakshmipati Rao, and Mr. Fernandez. I have practical experience of working in the engine room of vessels, ocean-going vessels for quite some time. So do understand what are the perils and what are the difficulties that today's seafarers must be facing, because being through that once. Later on, I went into the corporate world dealing with centrifugal separation technologies. And I have been ashore for quite some time now and seen how the corporate world also functions. And before I start, I can tell you that it's a different ball game altogether when you are in the engine room of a ship rather than when you are an industry ashore. I am aware of the fact that there are some people in the audience who possibly are of the students group or of junior engineer level. So my presentation, I will be starting with sorry, I'm getting a little.
Oh no. Forever.
I'll be starting with the fundamentals in the very beginning, just to refresh you gentlemen all, and then we shall move on to the modern technologies and the benefits of them. Concerning the theme of today, that is the maintenance, the ease of maintenance, the expenses that are involved, I will be touching on them briefly because I have not done the value analysis as such, but that has been already spoken about. So what is centrifugal separation? Centrifugal separation is, when you compare it with filtration, filtration fundamentally talks about solids, and the solids and liquid where the basic criteria is of sizes. And if there is a variation in the sizes, then you would be able to do filtering of the liquids and taking out the solids. It's a very simple way to explain it. And the medium can be anything. It can be screen, it can be mesh, it can be membranes. Okay. Centrifugal force is sedimentation, primarily is settling of the solids at the bottom. And there is a force associated with it. If you're talking of a settling tank, then of course the force would be the force of gravity. If you are talking of a shipboard centrifuge, then it will be centrifugal force. There is, however, a small element which goes usually unnoticed. When I ask most of my juniors and shipboard engineers, the normal notion is that sedimentation by a centrifuge is connected with the specific gravity difference between the particles, whereas filtration is based on size difference of the particles. I think there is correction required over here. Sedimentation by centrifugal force also helps if there is a size difference. So more heterogeneous the mixture, the better will be the centrifugation, the better will be the separation. More homogeneous the mixture, it will be more difficult for that to get separated. A simple example that I always quote to the juniors whom I train is that there are two types of milk available in the market. One is called pasteurized and homogeneous milk, and one is called plain pasteurized milk. If you get both these samples at your home, put them in a glass tumbler, put them inside the refrigerator, and next day morning, if you will see that the cream layer on top of the only pasteurized sample is a little thicker than the one that has been homogenized. Because homogenization actually reduces the globule sizes, and that creates more difficulty in what does it translate onto a shipboard maintenance application. One of the most important things that we need to see is that in the complete fuel oil treatment cycle, in the lube oil treatment cycle, we should not have any kind of shear stress. There should not be any kind of sharp edges, so that the more the heterogeneous mixture that can be maintained, we get better results. Centrifugal separation can be two-phase, which we call clarification, and centrifugal separation can be three-phase, which is solid, light liquid, heavy liquid. If this becomes too much of technical jargon, then it is contaminants. Light liquid is oil, heavy liquid is water. Okay. I just brought in the lower part of what you see over here is from my experience, and just to enlighten the audience over here that centrifugal separation also plays a very, very big role in other industrial applications. Their centrifugal separations are known to do different activities. For example, thickening in wastewater treatment plants or sewage treatment plants. You thicken up the solids so that the transportation becomes very easy. You do dewatering and deliquoring of wastewater or sewage before the sewage is treated, and you remove the water so that it is much more easier to handle, and you do again through a centrifugal separation activity. For example, the water removed from sewage treatment plant usually sometimes are being used, are treated back into drinking water. Singapore today has about 42% of its drinking water coming back from sewage treatment plants. Removal of oversized particles, we do degritting. This is a mining application. Then we have got classification in mineral application, fractionation of, for example, human blood. I was very surprised when I came from the marine background into the centrifugal separation business, and I realized that human blood can also be fractionated by a single centrifuge. Then there is a concept known as washing. If you want me to explain it in layman's term, it is generally used for turbine oil. The turbine oil has got certain components which are not soluble in the oil, but are soluble in water, and they cannot be separated just by, density differences. So what we do is we wash the oil. In other words, we infuse water into the oil, and then the contaminants get dissolved in the water. And we use centrifugal separation to take out the water, thereby purifying the oil. I just brought this up just to broaden the scope of these deliberations and to highlight the extent separation technology by centrifugation can go. Okay, the separation by centrifuges can go into different applications. I'm not going to dwell on this too much, but separators with solid wall bowl and separators with self-cleaning bowl is what is used on shipboard applications. Nozzle separators are not yet on shipboard applications, but decanters are. Decanters are being used on certain vessels in order to concentrate the sewage and the sludge, and it is extremely popular nowadays on cruise vessels, actually, where the sewage load is much higher than merchant navy vessels. Centrifugation separation technology factors affecting sedimentation. You know, if you just have a settling tank, you will be having the solids accumulating at the bottom. They will go down by gravity, and that gravity will be the force of separation. Now, if we are going to put the more number of plates inside the same sedimenting tank, then we will be increasing the area on which the separation will occur. So we come to one basic conclusion, that is, centrifugal separation technology is derived from the concept that sedimentation will happen better if you increase the force of separation, and sedimentation will also be affected if you increase the area of separation. Now, taking from the previous slide, this is what we do. We try to increase in a disk separator, try to increase the area of separation by putting the disks at an incline. This is more or less similar to the sedimenting tank with the plates inside. And we increase the force of separation by replacing the force of gravity and bringing in centrifugal force. So centrifugal force is many times more than the force of gravity, and more the number of disks, the greater is the area available for separation to occur. These are the two fundamental criteria with which we play around and design various types of centrifugal separation implements in order to manage the various requirements from different industries, including marine industries. The difference when we try to ask ourselves whether a certain centrifuge will work on a certain application, the calculations are based on a very simple theory. The total centrifugal force available compared to the force of gravity is called the G force. And the G force defines whether a solid with a certain specific gravity for a certain capacity can be separated or not. Please appreciate and understand that we are talking about very high centrifugal force, and this high centrifugal force is the reason you don't see too many brands as far as centrifugal separation technology is concerned. You can get quite a few brands for pumps, mixers, but you will not be able to get too many brands for centrifuges in the market. The centrifuges also work fundamentally on the principles of the Stokes law, and I'm not going into that right now too much in details because the time is limited. But if anyone wants to know, then of course my email is there and we can discuss it later. The other thing that is very much important for us to understand is the viscosity through which the solids have to settle down. It's easier for the solids to settle down in a diesel fuel oil than in a heavy fuel oil. So viscosity becomes a very important criteria for of the oil. And we play around with all these design parameters to provide the basic solutions in the market. applications in a shipboard engine room is power related, that is fuel and lubricating oil. They are used for the propulsion and the power generation engines, and also to the lubricating oil, which extends the life of the engine room, of the engines, and reduces all the maintenance costs. Lately, we have had this pollution-related bilge separator. At the time when I was on board ships, we never had centrifugal separators working as bilge separators. They were basically filter coalescer arrangements which were there, but they were not really all that successful. But today, the world has shifted to bilge separators, and the separators which are in the bilges are working on a different parameter as compared to fuel oil and lube oil. In fuel oil and lube oil separators, the light liquid is more and the heavy liquid, that is water, is less. Whereas in a bilge separator, the light liquid is less and the heavy liquid is much more. So we are playing around with the interface and where to position the interface within the centrifuges. This is again a design parameter, and with that, we can design our centrifuges for different applications and different requirements. Finally, of late, we have the pollution-related centrifuges, which are there for the scrubber units. Lately, from 2020 onwards, emission controls have become really stringent, and ships are supposed to maintain. That is what Mr. Rajshekhar was just now talking about. If you are having low sulfur fuel, of course, there is no issue. But if you're having high sulfur fuel, you need the scrubber units, and the scrubber units need the water, which have to take out the particulate matters, and then the water has to be recirculated. But before that, the centrifugal separator makes sure that the solids within the water are taken out. These are the general efficiency standards. I'm not going to go through them too much, but we have to be careful of the catalytic fines which come into heavy fuel oil, especially in today's times when the regulations are becoming more and more stringent. And the parameters of separation efficiency are specific gravity, size, shape of the solid particles, viscosity of the oil, the specific gravity of the oil, and of course, what we just said. Let me sum it up: the total clarification area, or the discs in the bowl, the acceleration, that is the speed of rotation of the bowl, and throughput, that is the rate at which the oil mixture is introduced into the separator. The individual components, of course, must be mechanically separated, and that is one of the basic requirements that we work with. The other part, as we were just discussing, is the viscosity. That is affected seriously by temperatures. I'm just putting this on record because if we have to take some thumb rules as to how much should be the separation temperature for the various types of oil that are used in the engine room, these are the temperatures which are mentioned over here, and the alarm thresholds which are provided for maintenance are also mentioned. The issue is that bunkers are taken from different locations, and sometimes there is a question of the quality of fuel that is coming on board. There can be also sometimes questions of incompatibility. So what do we do when our centrifuges there is a demand on the centrifuges to clean substandard furnace oils or substandard lubricating oil? The only solution we have is to reduce the throughput going into the centrifuges, because for obvious reasons that we cannot increase the discs in the centrifuge, neither can we increase the RPM of the centrifuge. So all that we can do is to try and make sure that the throughput is reduced. The throughput reduction increases the residence time of the liquid mixture inside the bowl. That in turn increases the effect of the centrifugal force, and hopefully better separation takes place. I have just put one slide to explain the desludging mechanism of a modern separator. This is how the bowl closes. It's a totally hydraulic arrangement, the picture that I am showing. And then we fill the bowl with liquid, that is the oil-water mixture. And as we fill it up, the centrifugation takes place. The solids accumulate to the outer periphery. And then we need to push the solids out. So we fill this up with water in order to ensure that when the solids are pushed out, it is water which is desludged and not good oil. So this process is called displacement. And then we move the sliding pistons and open the bowl up, and the solids get discharged. Okay. After that, it is the process repeated again in order to close the bowl and start the centrifugation all over again. The same thing can be also used by other manufacturers, which has got hydromechanical way of, making sure that desludging arrangement takes place. What is important for us to remember, and then we go back to maintenance of these machines, is that all this is happening maybe in a centrifuge which is rotating, a bowl rotating at 8,000 RPM, carrying maybe about 5,000, liters, 5 meter cube of liters of fuel oil. And we are not going to stop the centrifuge, but we are going to open and close while the centrifuge is running. This is important for us to focus upon, because dynamic balancing, while the bowl undergoes so much of stress and strain, is paramount importance. If this dynamic balancing at any point of time is disturbed, then we will have accidents on board and there will be severe consequences. So it is important for us to have safety aspects metered into our systems and working with the systems. Actually, when I compare the shipboard application of centrifuges with the industrial application of centrifuges, because on ships we have qualified and trained personalities, whereas in industries sometimes we do not have qualified and trained persons working with these kind of machines. We observe that whereas on board ships such accidents are unheard of, there may be a few disturbances in other industrial applications. Okay. The generation of centrifugal separation technologies. When I started my career back in 1977, we came across gear-driven centrifuges. Gear-driven centrifuges have the bowl is on a vertical spindle, and then the bowl is rotated by the vertical spindle, which gets its drive from a worm wheel arrangement and a bevel gear arrangement. Okay, these were the initial designs that came into the market, and even today they are prevalent in many places. But reality is that the maintenance requirements are very high. There are too many parts, and there is very low transmission efficiency as compared to the modern technologies which have come in. With the improvement of the polymer technology, the belt-driven separators have become very, very common. More or less today on shipboard applications, most of the centrifuges are belt-driven centrifuges. There are many advantages of this design. The frictional heat of metal-to-metal friction in a gear-driven centrifuge is totally taken out. There is no lubrication required for removing frictional heat. Lubrication in these belt-driven centrifuges are only to ensure that the bearings get lubricated properly. The bowl height can be lowered because we don't need to put the bevel gear or the worm wheel in between. And if you lower the bowl height, the metacentric height of the bowl reduces, thereby increasing the stability of the machine. And finally, the maintenance cost of the spare parts are drastically reduced because quite a few bearings and seals are no longer required. But we have not stopped at that. There are now what is known as direct drive centrifuges. One of the major manufacturers in 2018 in the SMM exhibition first launched these direct drive centrifuges, and gradually they are gaining popularity. These direct drive centrifuges means that the centrifuge works virtually like a pump. That means you connect the bowl directly onto the motor. No gears, no belts. The big question now is, what is the difference between a pump and a centrifuge? A pump, the pump is connected directly to the motor, and a centrifuge could have been connected directly to the motor. The difference is that in a centrifuge, the momentum must build up gradually to the operational speed. If we cannot build up the momentum gradually to the operational speed, then we will have a situation where everything will be ruptured. Now, the variable frequency drive technology has become so modernized that we take advantage of this, and we put a VFD in between the motor and the bowl, and the VFD is programmed so that the rotational speed momentum is gradually increased, and thereby we have a situation where we can eliminate all drive maintenance parts, making it more easier and more cheaper to for the future. This has even been further improved by saying that the drive arrangement has now been put into a capsule or called a cartridge. So on board ships, there is no need today to open up the drive and replace the parts inside it. The company says you just take that cartridge out and replace it with another cartridge and send the cartridge back to us, and we will repair it and send it back to you. So, gentlemen, you can easily visualize what is going to be the inventory cost reduction of manpower that is going to be put over there in order to run and maintain these centrifuges. This is what has happened. 2018 onwards, these centrifuges have already come into the market, and I am looking forward to see better designs even as we go along. The efficiency of a gear-driven centrifuge transmission efficiency is 76%. That is agreed by most of the manufacturers. The efficiency of a belt-driven centrifuge is 90%, and the efficiency of a direct drive centrifuge is about 95%. You see, as the various technologies are being available, manufacturers are using it in them. For example, in the belt-driven centrifuges, these are endless belts. Polymer technology is very good today, so we can go in for better belts. These are not belts which have to be aligned specifically. They are self-aligning belts. So you see, all these technologies which are available in the market, as they come in, they will help us to design better machines. Centrifugal separations, the solid bowl separators, these are the first generation separators. We call them the first generation separators. These separators are the ones which we stopped after a period of running, and we took the solids out, manually cleaning them. These were there, but gradually they are no longer, they are becoming extinct because number one, because the capacities are increasing, and if the capacities increase, then you cannot keep on periodically open this bowl. Similarly, when we talk of the drive that I was discussing, as the capacities increase, the load on the frictional drives or the belt drive becomes too much, and sooner or later, it will be direct drive centrifuges, which we will see in the market, others gradually becoming extinct. Self-cleaning separators. Separators take a decision by themselves. Separators are time-based, controlled for ejecting the solids out, as we saw the animation earlier. So on basis of time, the solids get ejected, and this is an automatically programmed process. But the world has not stopped at that. The new design is the self-thinking design. If this is too much of a technical jargon, then the people who are listening to me would be familiar with the unitrol system of GEA Westphalia separators, or the ALCAP system of Alfa Laval, or the Hayden system of Mitsubishi Kakoki. In this case, the separator itself takes a decision not based on timers, not based on control arrangements, but the separator itself takes a decision when the solids have accumulated and when they are to be ejected. The sensing instruments are all kept outside, and those sensing instruments are going to tell the separator that it is time to take an ejection, or it is time to push out the water. Thereby, what happens is that the maintenance of the separator becomes easy, as we do not need to continuously monitor what kind of solids are going to come in. And of course, these, as we are not doing it periodically and timer-based and mandatorily, the maintenance costs also reduces because the wear and tear on the bowl parts becomes less. But the world has not stopped at that. I will go on to my last slide, which is to talk about a patent which has just come into the market and has been awarded to one of the major manufacturers in 2021 in the month of October. And this could be a game changer for the future. This is what is called an intelligent separator, or a smart separator, or a smart centrifuge. And artificial intelligence is now coming into play over here. We have now centrifuges which have been designed with sensors inside. Visualize a scenario where maybe we don't need to desludge the centrifuge, but just have valves within the bowl, see point number 502 or 108, and these valves will be opening up periodically on their own to eject out the solids. Visualize a scenario where the sensor inside the centrifuge will give a feeling to the operator whether the solids have accumulated or whether the water is getting contaminated. We are looking forward to a terribly exciting future. And when this comes, then the number of parts will be further drastically reduced, the maintenance cost will come down, and it will be a much more safer machine to work with. This has not practically been launched into the market yet, but these are there in the public domain. I have taken it from Google Patents. It's an exciting kind of a concept. I hope the manufacturers proceed with this design, and hopefully there are many more exciting things to come. I was given a specified time to address this gathering. I did not try to go into the further details. Thank you very much for listening to me. And this is the patent that has come in, and hopefully this will be the future that we all look forward to. Thanks to the audience and to the Institution of Engineers. It has been a very pleasant discussion with you. Thank you very much. And later on, if there are any questions, I'll be very happy to answer.
Thank you, Mr. Amlan Banerjee. And it's absolutely interesting, especially, it's very interesting to know VF drives, and of course now the intelligent separators, smart separators, which of course we will try to sum it up a little later. But I will go to the eminent speaker. My next speaker is Mr. Elson A. Fernandez. I will briefly go through his credentials, his profile. It's welcome to you, sir, and it's absolutely fantastic to have you in this forum. He's a chartered engineer and fellow in the Institute of Engineers India, member of the Institution of Engineers, Engineering and Technology UK, and member of Leaders Excellence at Harvard Square, USA. Specialized in marine control systems and automation, Latvia, and member of World Authors Association, Non-Fiction Authors Association, USA, and an Amazon Central Certified Author. World's #1 author in marine engineering education, with 50 unique titles and 70 copyrights, about 50,000. I mean, this is about the marine engineering education. Awarded Promising Indian of the Year 2017, one among 39 global Indians who were awarded. Fantastic. 43 years of professional experience in 20 countries with about 50 nationalities. Absolutely a terrific profile, and we are very, very glad, sir, to have you in this forum and listen to you. And Mr. Fernandez is going to speak about maritime operations and system maintenance and the emerging trends in the shipping industry. Welcome, Mr. Fernandez.
Thank you.
The forum is yours now.
Thank you, sir. Permission to share the screen, sir.
Yes, sir, please.
I hope you can see my screen.
Yes, please go ahead, sir.
Yes. So, without much ado, I understand that we are slightly behind schedule. I will go ahead and just want to let you know that, I've had the opportunity to start writing a book with the eminent Dr. Bhandarkar himself. We just had a chat over the last few days, and we'll be co-authoring this book, Maritime 4.0, The Future of Seafaring. So without much ado, I will just tell you briefly what we are going to do in the book and what I will be presenting to you. So the topics explained in the book are new emerging trends in the shipping industry, current challenges, opportunities for innovation, introduction to Industry 4.0 and elements of Maritime 4.0. That is the child of Industry 4.0 itself. Then CPS. I will be piggybacking on the fantastic presentation by none other than Rear Admiral Ranasinghe, who gave us a great insight into maintenance. And of course, Dr. Rajshekhar himself, who spoke a lot. So the next thing is the impact of Industry 4.0 on the maritime industry. Barriers, of course, we will experience certain barriers, but there are also drivers. And then we talk about smart ships. And finally, we will look at the emergence of new business models. So the topics to be discussed today are few. That is emerging trends. That is very important because maintenance is a science by itself. As some oldies would call it terror technology. But today it's gone beyond that. It's more a science. It involves so many facets. The current challenges that we face in the maritime industry to have a paradigm shift from traditional maintenance to intelligent maintenance. Then, of course, cyber-physical systems, impact, barriers, and emergence. So, a little bit about Industry 4.0. Long before we were born, in the year between 1765 and 84 came the first industrial revolution. Mechanization, steam power, coal, discovery of oil, and the weaving loom, etc. were the first, you could say that angles or faces of the diamond that was being formed that we are enjoying today. The second industrial revolution came around 1870, and then came the Model T Ford also. Mass production, assembly line, electrical engineering, and so on and so forth. I was born towards the end of the second industrial revolution, but being in a country that was still progressing and still taking off, experienced a lot of the second industrial revolution equipment, as my father was an engineer. And I grew up in an engineering environment. But then Industry 3.0 came in 1969. I was 7 years old then, when automation and the first computers came into being, electronics, and then they discovered nuclear fuel. And today, 2010 onwards, roughly around 2010, we came into the Industry 4.0 revolution, which has 9 pillars. I will not be focusing on Industry 4.0's 9 pillars, but that is addressed in our book. So here we are talking about CPS, about Internet of Things, Industrial Internet of Things, networking, and new fuel technologies that we will be talking about a little bit in this presentation today. So what are the new emerging trends in the shipping industry? As we see that, the fossil fuel industry has had a stranglehold on us for years and years and years, to the point that today people are looking at organic fuels. Now we must be wondering what exactly. I fortunately worked for a company in the US known as Bloom Energy. Some of you may have heard about the Bloom box. So I was in the pioneering team of about the first 300 people that realized a concept into a product. And our first customer was Google. But you'd be surprised today, Samsung Shipyards has tied up with Bloom Energy to build ships using hydrogen-driven solid oxide fuel cells that will drive electric propulsion systems, which means no main engine, which means 20 to 30% more cargo space, 5 to 6% increased efficiency, larger ships, more efficient ships, and so on and so forth. So now, considering the fact that that is a huge shift, a paradigm shift from where we are to where we want to be, there are still fuel standards that we have to maintain, and as we are still using conventional fuels. So fuel standards are coming in. We'll be talking a little bit about it as we go forward. Basically, the IMO has set standards that we must reduce emissions by 50% by the year 2050. In fact, just today I read an article where they said that from the year 2023 onwards, we'll have to file an annual efficiency report. Each ship has to file an annual efficiency report. Thanks to Amlan sir, who spoke about scrubbers. We are talking about reducing emissions. We are talking about NOx, SOx, and intelligently monitoring emissions. That is one part. Then seamless systems and process integration is another emerging trend, which we are looking at in terms of right from concept of vessels, concept of platforms, concept of building ships to operating, maintaining, and even the logistics part of it. Then most of us are aware, at least the veterans and the eminent panelists and members of the Institution of Engineers know that we have moved on to, autonomous ships. They have tried out autonomous ships. It is successful, but it has many, many underlying technologies that support it. One of them being blockchain technology. So blockchain technology is nothing new. It is just an amalgamation of huge ledgers of data being brought together, where we can use this data from time to time, transparently use them, integrate them, and take things forward. Now, one major problem that the industry faces is spares, production of spares. We know that, Sir Dr. Rajashekar, I believe you were a chief engineer. Operating a ship without a spare meant that she was kind of paralyzed. If you had a major spare that was missing. Today, imagine you could have a 3D printer in the next port printing your part, saying that in the next 2 days you're going to get your part rather than waiting for a week. Downtime has been reduced. Robotics and bots. We know that robotics is a challenge in the shipping industry, considering the size of the vessels, considering the profile of parts, considering the huge weights that they have to manage. But slowly, with bots and with intelligence, they are becoming more and more intelligent. So those are the emerging trends. The current challenges, a few of the speakers today mentioned about rising fuel costs, lubricants, shipbuilding, managing demand versus time. The demand is increasing, time is reducing. There's a paucity of time. There are more and more passengers. There's more and more cargo. 90% of the world's trade we know is through shipping. So what do we do? When autonomous ships were conceived, they said it will never function because of bad weather, because of expensive equipment. But today we are looking at scalable solutions. Quick communication and control. We understand that internet connectivity at sea is a huge challenge, but thanks to satellite communication. One major area is where people are sharing information more transparently now. I'm so lucky to be part of this gathering today, to have learned so much rather than present. Because all this time, even though I've been an author, I would have to go to libraries, internet, talk to experts. But today, just sitting in a room, I was able to learn so much rather than present. So global warming, I'm not going to stress upon it because most of us know about global warming, and I already mentioned. One thing is that we will have to cut down the life of vessels and not let, I sailed on a 36-year-old vessel in the year 2008. I don't think that's going to happen anytime soon. They're going to get rid of vessels. Lifespans are going to be reduced. Now, earlier we said a ship cannot run without a main engine. Today we say ships can run without main engines. We've got alternate fuels. As I just mentioned about SOFCs and hydrogen, electricity and other things. So digitization of supply chains. Now we know that the moment we talk computers, the moment we talk internet, the moment we talk about big data, and the moment we talk about, anything that is related to Internet 4.0, oh, this is not my cup of tea. So this is something that we have to accept. We are going to live with it on a day-to-day basis. There's a lack of scientists, but more and more people are coming together. And of course, trade tariffs are a kind of a menace for us. Huge trade tariffs are dragging the economy down, but with more efficient ships, faster ships, better logistic management, better intelligence, we will be able to go forward. Piracy, I'm not going to delve on it, but there are certain parts of the world that are plagued by piracy, labor shortages, people who are refusing to move from traditional technologies and take on more advanced ships. I have seen my own friends, colleagues, seniors say that, Baba, I'm not going to operate without an electrical officer. I'm not going to operate on a UMS vessel. I will never go on an autonomous ship. I don't want to die. I have a family to take care of. But today, people are moving in that direction. So the next thing that we look is transparency and traceability. That is a huge thing that we have to do. The modern generations are becoming more transparent. They're being more open. But at the same time, you might have read in the news recently, a ship was arrested because it had drugs tied to its hull. And the crew and the leaders on board and the captain and the chief engineer, etc., they had no clue who put that drugs to the hull. But the authorities blamed them. So now traceability is going to become better and better with more and more intelligent systems. Better SOPs for transport and traceability will be the order of the day as we go forward. Now, cyber-physical systems is where we come in. And the main focus of today's presentation is CPS. Now, with all due respect, Admiral Ranasinghe gave us a beautiful insight about predictive maintenance. So what I mentioned earlier was piggybacking on his presentation. Here we are using, and as he mentioned, Sri Lanka is moving towards computing and intelligent technologies. So this would also be something that would be of the future and is currently being used. CPS is an integration of computing, manpower, networking, and physical representation of a processor entity. Now, what is the meaning of this? This is you have manpower who are taught computers and internet, who have intelligent systems to support them. And I will come to about predictive maintenance slowly. The system was so intelligent in CPS, they could be self-adaptive also and self-optimize. Eventually, it will be telling you what to do. AI will be introduced. AI will take you forward and tell you this is not the right way to go. Believe me, when I was working in Blue Energy, I was head of operations where we started off with one unit and I controlled it from Mumbai. It was operating in none other than a lab in NASA, Bayshore, NASA in California. In 5.5 years, we were operating 150 megawatts of power of fuel cell technology with how many operators? I'm sure nobody will guess. One operator, one supervisor, 24/7. But I, being the head of operations, we kept the operators to work for 6 hours at a time. And we could not focus because it was. But then what would we have behind us is CPS. And this is where the advantages of CPS can be seen is integration of machines, men, computers, systems, data, analysts, and everything. Interaction between humans and CPS is very, very easy. Today, we've got predictive tools like Jump. There's a software called Jump where we could extrapolate data. Then we even had many historian softwares where we could see trends and we could see that where the system would go. So managing uncertainty was a piece of cake. Imagine one operator being able to say that, sir, there's a system that is going down and we've got to take care of it before it trips. Who told you? The system told me. Who told you? The analyst just pinged me saying that, look at this data, I can see a runaway. Scalability is there because of modular features. Agility and flexibility of systems is fantastic considering that we are innovating on a day-to-day basis. And when you say faster response time, I would add one more thing, real-time analysis, real-time operation, real-time data, real-time alarms. It's not that something happened yesterday and I'm told today. So here I participated in something known as a Bold Idea Challenge in the APAC edition by Schneider. It was an agorized challenge. Most of engineers might have received emails requesting them to join these challenges. In 2008, a friend of mine, Vikas Dhawan, and I, he's a robotics engineer, instrumentation guy. I'm a poor mariner with naval experience in submarines and merchant navy, and of course, a writer, researcher. We came together and we put this thoughts, and we didn't realize that what we are moving forward to is Maritime 4.0. The same thing, rising costs, penalties, manpower reduction. So what I did, I said, man, let me do something. I'll bring my 5 years or 6 years of experience with about 300 PhDs in Bloom Energy, come here and sit down, because Bloom Energy grew from 300 people to about 3,500 by the time I left. So we had about 300 plus PhDs. And there they went by data. Today, you know, they say many people pray for miracles. The smart people bring data, you know. So this is what it is, predictive analysis, real-time monitoring. And to meet the challenges, we coined a term called EWS. It is not taken from the internet, not taken from Google. This is just what we thought about. It might have similar brothers and sisters on the net. So what are the things was to provide critical alerts. We know that if you could provide a critical alert on a mobile, internet, on a tablet, on a computer, or just activate a red bulb in your room to say that, hey, the system is going down, I could do something even before it went down. So here we can use sensors. Now, most of the ships today have a lot of sensors on board. Why don't we tie them into a LAN or a CAN and bring it onto the van, as you will see when I come to the next slide. As you can see here, today ships are not isolated. My dream is to have a mission center where we will be able to monitor our entire fleet. Companies could sit down in a mission control center, have a data warehouse, analysts sitting behind, monitoring. Now, if you think this is a fallacy, this is not. Boeing monitors its aircrafts. GE USA had a system of monitoring all locomotives that are running on a day-to-day basis in US. So this is possible. It's only that we should accept and say, go forward. So then this will take care of manpower, because costly manpower, the first thing owners think of is get rid of manpower. So unbudgeted expenses and so on and so forth. So these are caused by the things that we already spoke about. So I will not delve too much into it. Now, enabling technologies in industrial IoT, smart sensors, analytics, and advisories. So this is about why. This is because it has a very winning combination. There's a huge market penetration. If you see that we've got about 50,000 plus ships today. If we penetrate 1,000 ships at a time, 500 ships at a time, 100 ships at a time, we're going to have better ships at sea. Anybody in this audience today, in this August gathering, if you'd like to join us in this project, I'm going to have it as an open source project. Please join us. Let us try to make India the leader in this. Although we have got many players in the world. Now coming back, we will see that, I will skip the slide. We will come back to CPS, milk run. Milk run 4.0 is something like in early days from cow to end user, to mother to child. Maybe in between there was a villager delivering it at the door. A poor person, like when I was a child, I waited for Akka to come. I waited for that Didi to come to the door to give my milk. And if the cow was sick, we never got milk. But today, take the case of Amul. The milk run is fantastic. They are able to cater to each and every person's likes, dislikes, wants, low fat, high fat, double toned, triple toned, full cream, cheese, etc. So that if we incorporate into our operation systems and look at good logistics, so that logistic management is something that where we talk about production logistics and delivery. Production logistics is one, delivery is the other. Cloud computing today, all of us talk about cloud computing. Your own computer at home could serve as a server as we have gone into distributed clouds. The other thing we could do is platform as a service, infrastructure as a service, or just software as a service. You could also be a player, like how people talk about Bitcoin, all of us sharing one Bitcoin. We could also share the cloud. We could also be, we do not have to depend on Amazon cloud. We don't have to depend on big players. We could also be there. Computer simulation, robotics and automation, these are the impacts. CPS, as we have spoken about corrective and preventive maintenance earlier, CPS is nothing about holistic asset visibility. It is something, improvement of preventive maintenance, but here we are using huge crunches of data. We are able to predict, increase the asset life cycle, and downtime is only in an unforeseen event. Now, virtual reality and augmented reality is something that can be used in training, used in fault diagnosis on board, used in predictive, used in understanding how a new system works, and so on and so forth. If you see VR and AR, they have, it's in fact, this forum is not possible to cover the whole things, but I just wanted to let you know that VR and AR is going to play a massive role. PDA, big data, where the huge ledgers of data are going to be used to help us predict and help us use and help us learn. And then we come into automation on process via bots. Autonomous ships and barges, we already spoke about. Bots can take care of, calling crew on time. Bots can be called, it can be used for sending out emails, orders, predicting, and picking up bits of data and sending out work orders, ordering your inventory, alerting people. If you go to HDFC Bank, EVA is waiting for you. It's nothing but a bot. But there are some barriers like high cost of implementation, and many people don't want to. Today, if we say, let's have a smart home, we'll say, Chodo na yaar, why don't we just have few switches in the house? Privacy issues, hacking, cyber security, that's a big concern. But today with cyber security, we can. Lack of skilled staff is another big thing. Tech integration, of course, people are working on it. People are getting more, interested. And standardization is one thing. I would say my standard is the best. You would say your standard is the best. One country would say that our standards are the best. But somewhere we've got to come midway and say that let's do it. So now, emergence of new technologies is sharing economic business models. We've got to come together as on one platform and say that, hey, I don't have $5 billion to implement this. Why don't we all come together as a group, as a consortium, and let's do this. As I told you, our EWS program is now open source. I can share all my thoughts and ideas with anybody who's interested. We could take it forward. I've got the alarm to stop. So here, personalization of economy business models and which are curated by experts. So we will say that, sorry, here we will talk about personalization. Everybody would not want like an OPEX model or coming together. They would want to maintain their own platform, and you spend more money. You spend more money. That's just about it. So finally, replenishment of economic business models is using smart sensors, IoT, and such things that we already discussed. And finally, X as a service. X as a service, we must be wondering, what is X as a service? Anything as a service. Anything as a service. Internet of things, Internet of people, Internet of design, Internet of systems, Internet of anything, Internet of everything. Now, people could provide you a service at home. I am actually 52 kilometers outside Bangalore city in a village with only 5 houses around me. But I have the internet connectivity. And this is the final thing. Looking at the future, what is the future? The future is we are going to have Industry 4.0. And with this, I would like to end. Thank you, Institution of Engineers. Thank you, eminent panel. Thank you, moderators and MC. Thank you for the opportunity. Jai Hind.
Well, that was a scintillating talk from Mr. Amlan Banerjee, as well as Mr. Elston Fernandez. Thank you, sirs. We have been able to see your years of experience being put into it. And Mr. Elston Fernandez, it was wonderful to see the passion with which you have spoken about your subject and brought us up to date as to where we stand and where we go from here. Thank you, sir. From here, ladies and gentlemen, I come to the introduction of Engineer V. Lakshmipati Rao, who's the faculty at HIMT Visakhapatnam, and he also happens to be the co-convener of the 34th National Convention of Marine Engineers. He has 36 years of experience. My goodness, we really have a phenomenal number of experienced faculty over here. But before I go ahead and introduce Mr. Vuna Lakshmipati Rao, I really must bring it to the notice of all the panelists and the attendees that today our chief guest, Dr. Rear Admiral KWARI Ranasinghe, spoke to us from hospital. Mr. Elston Fernandez spoke about the fact that he is speaking outside of Bangalore. Well, our chief guest was speaking to us from hospital. Unfortunately, he is down with a fever and a bad case of flu, which has made him very weak. However, the soldier that he is, he soldiered on because a certain expectations were there, and true to his uniform, he gave his lecture from a hospital. So, ladies and gentlemen, I'm sure each and every one of you will join me in commending our chief guest, Dr. Rear Admiral KWARI Ranasinghe, for the wonderful talk that he has given us in spite of debilitating circumstances. Thank you, sir. From there, I come to Mr. V. Lakshmipati Rao. He's a marine engineer with 36 years plus of experience.
Commander Prasad,
So,
I think we request moderator to be brief, sum up, very short sum up. So please stick to our timeline. Very brief.
right.
Yeah. Okay. Okay. Thank you, Commander Bandakar, and I think the talk by both Mr. Amlan Mukherjee and Mr. Fernandez have been fantastic. You know, coming to the talk of Mr. Banerjee on the centrifuges and the kind of centrifugal technology, the growth of the technology to smart centrifuges. Because I always consider, as a marine engineer, I consider this is the heart of the ship. Many of you and our brother, all of you will agree with that. his talk on the significance of the fuel oil cycle, and very importantly, the significance of viscosity of the oil. There's a lot of science to it, and it's very well brought out by Mr. Banerjee. And also washing technology, that's interesting to know, especially for the younger generation. And with nozzle separators coming in, and the VFDs, that is variable frequency drive technology coming into the market, especially for the centrifuges, and with smart separators. I think we are seeing a very good future on this technology, and very good technology to be coming to the maritime industry also, though it's available in the industry on the land. Very fantastic talk, sir. Thank you very much. And we really appreciate your talk. And I would also request you, maybe you can come up with a small technical article on this, especially on the smart separators and, some of the latest technology, so that it will be useful for the entire community of mariners. Thank you so much. And coming to Mr. Fernandez, a fantastic talk, sir. It's especially on the emerging technology in the shipping industry. And you also emphasized on the, smart ships and the importance of innovation in doing the things and doing the things right way. And with technology coming in, especially the digital technology coming in, and with improved sensor technology, I think sometimes some pessimists may say, okay, these are not so reliable. I've heard this from my own friends, not now, maybe a few years ago, but now the trend is changed and it's highly reliable systems. And yes, as he rightly said, there is a fear of cyber security, but that is also addressed parallelly, and there is quite a bit of quite a strong security systems are available to ensure this technology is safe and sound. And he also talked of alternate fuels to reduce the emissions, which is very interesting. That's the core of the green technology for the maritime industry globally. And I'm very happy. And also, he also talked of fuel cell technology. And, as everybody is aware, there is already one ship available propelled by the hydrogen. And it's a first ever green ship completely, which, of course, people used to say, no, having hydrogen on the ships is not safe, and it's explosion prone and all that. But all those concepts are very old. Now there is a proper technology available to address the safety and how these explosions can be avoided. There are technologies available, and we have seen the ship is sailing fine. And we are also, as an India, as the country, we are also getting into developing these green ships. It's a very, very nice talk, and definitely both the talks are useful to the audience. And I also request you to come up with a short article. I know you're coming with a book with Dr. Bhandarkar, but I think a short article, a 2-page article, would definitely help the mariners. Thank you very much. And there are, I think, I can see one question. This is an anonymous attendee. He asked for some contact details of Mr. Ellison. I think that can be shared by the administrator. Otherwise, if there are any questions from anybody, I'm sure the speakers would be happy to answer. Attendees, yes, participants. Yes, please. Yeah, Mr. Lakshmipatra.
I think most of the questions, in fact, all the questions have been answered by the respective speakers. Yes. I think we can go for vote of thanks now due to the constraint of time.
Yes. Thank you again, and I welcome Mr. Lakshmipati Rao. Thank you.
Okay, sir.
Mr.
Good
V.
evening to all of
Lakshmipati
you.
Rao. Mr.
Sir?
V. Lakshmipati Rao has been a chief engineer from 1981 to 1997. He has a phenomenal career wherein he has been a fellow member of the Institution of Marine Engineers. He's a fellow member of the Institute of Engineers. He has obtained the title of Professional Engineer from the Engineering Council of India. In terms of honors and awards, he has a citation of merit for significant contribution to services received from the Visakhapatnam Port Trust in the year 2008, 2013, 2014, and 2018, respectively. So, ladies and gentlemen, we are coming across a person with 36 years plus of experience as a marine engineer, Mr. V. Lakshmipati Rao.
Thank you very much, sir. Thank you, Commander Prasad Padye. Respected ladies and gentlemen, on behalf of the Institute of Engineers India, Balapur Local Center, it gives me a great honor and privilege to deliver the vote of thanks to this August gathering here. Before going further, with the permission of the organizers, I would like to tell you about 34th National Convention of Marine Engineers and a national seminar on the theme Contemporary Developments in Marine Technologies, which will be held on 15th and 16th October 2022 at Visakhapatnam. This is organized by the Institute of Engineers, Visakhapatnam Local Center, in association with DRDO, Ministry of Defense, Government of India, Visakhapatnam. I request you all to participate and make the seminar a grand success. For details also, we can visit ieivisakha.org. It will be there. Okay. Now coming to the vote of thanks, sir, I will not take much time. So I'm very grateful and to see the August gathering and giving the excellent speeches with their experiences. Very, very thankful, sir. Let me first of all start by giving the glory to the Almighty of God by making today's webinar a grand success. Thanks to our President, Institute of Engineers, Dr. H.O. Thakre, for his valuable address. My special thanks to the chief guest, Dr. Rear Admiral K.W.A.R.I. Rana Singhe, Director General of Engineering, Sri Lanka, who gave an inspirational speech. Today we had an opportunity to hear your thoughts, and this will surely be going to increase in the coming future, sir. I would like to express our sincere thanks to Dr. G. Ranganath, Chairman, Committee for Advancement Technology and Engineering, for giving an excellent coverage on the theme, like father and guide, as Dr. Bandar said. And I wish to express our gratitude to Dr. Rasak, Group Director and Chief Scientist, Vessel Management Cell, National Institute of Ocean Technology, Ministry of Earth Sciences, Government of India, for providing encouragement in his speech with new ideas, techniques, and strategies, being a moderator. I also wish to express our gratitude to distinguished faculties, Mr. Amlan Banerjee, Director, House Centrifugal Technologies, and Mr. Elston Fernandez, Vision, Author, Marine Technologies and Control Systems, Co-founder, College Education Training System, for their excellent analysis on the set theme. I'm grateful to Commander Dr. B.M. Bandarkar, Chairman, Marine Engineering Division Board, for providing encouragement in conducting various seminars and webinars, which is very much useful to our marine industry. And we also acknowledge our gratitude to retired Commander Prasad Padye, Project Director, Marman Engineering and Shipbuilding, presiding the function and with a systematic way. I would like to thank all the participants for sparing their valuable time for this wonderful webinar today. Finally, I extend my thanks to staff of Institute of Engineers, Headquarters, Technical Department, for their enormous cooperation in organizing this event. Thank you all. Thank you very much.
We thank Engineer V. Lakshmipati Rao Garu for delivering the vote of thanks so nicely. Thank you, sir.
Thank you, sir.
I think we can call it a day.
Thank you.
Yes, thank you so much, everybody. Dr. Bandarkar, thanks again for your energetic initiatives. Okay, keep it going strong, sir. Keep it going strong.
Sir, hope to see you all in Vizag next month, sir.
Yes, sir. Dr. Rajsekhar already promised he will be there.
Sure, sir. Sure.
Okay.
Thank
you
you.
very
Sure,
much.
sir.
Right.
Thank you. Thank you. Thank you. Sir.
Thank you, sir. Amlan sir, namaskar.
Hi, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Namaskar.
Thank you, sir.
Thank you very much.
Kamble sir, thank you, sir. Okay. Thank you, Prasad. Thank you, Commander Prasad.
Thank you, Bandakar sir. Thank you, Commander Prasad sir. Thank you, everybody.